heavy at first, and it's not easy to bring all that up here. That's why we're trying to conserve the water as much as possible and reuse also the old water. So we have a very good life support system that even reuses the water from urine, from we breathe out, and it makes it very clean again, and then we can reuse it. By the way, that's the same, it works on Earth. Over. Hey Lauren, so on the inside we have about 21 degrees, it's really nice, we can float around in t-shirts, but on the outside we cannot measure temperature because vacuum does not have a temperature. We can just measure the surface temperature of the space station, and that varies. If it's in the sun, it's about plus 130 Celsius, so more hot than boiling water, and if it's in the shade, it can cool down to minus 130, so it's very, very cold. And every time we fly around the Earth, that changes, of course. Over. It can cool down to minus 130, so it's very, very cold. And every time we fly around the Earth, that changes, of course. Oh, really good question, Maya. We do a lot of experiments taking away the factor of gravity. Like if you want to study how different metals in the molten metals mix up, we can only do that up here where those metals mix up nicely. If we try the same experiment on the ground, it would not work. There's no way to perform those experiments on Earth. Or another one is, for example, we look at cancer cells, so we grow cancer tumors in a way, and they grow differently from Earth. On Earth, they're in a petri dish, they're two-dimensional flat, but up here they form like little spheres, and that's much more similar to how a tumor looks in the body. So actually up here we can test medication much better than down there on Earth, because up here we have more realistic conditions. And that's just two examples for so many. All the experiments that we do up here are not possible on Earth at all. Over. More realistic conditions. That's just two examples for so many. All the experiments that we do up here are not. Oh, that's a difficult question. I don't know which one. We did so many. I mean, we have more than 100 already. I think one of the ones that I'm most impressed of is one where we can look into live cells. We have a microscope where we look into the cells and what they're doing while they work. Also, of course, many experiments we are giving data. We are the experiment subjects, meaning like we look at our immune system, we take our own blood and investigate it, and that way we help people on Earth who have illnesses, different illnesses on Earth, and that way we can contribute to helping a lot of people down there on Earth, and those are usually the ones I like most. Over. Oh, very actual question. Just yesterday I assembled a new life support system that we flew that was built in Europe, and that is a new system that can produce oxygen from water, and it can reclaim water from the space station atmosphere, make new water, new clean water out of old water, and that's a system that we need when we fly longer into space. When we fly to Mars, we need a system like that, and that's why we're constantly trying to improve and make our systems better that we have. We're almost there, building a really good life support system, but not quite yet, so we need to train and test those systems more and more, and that is something that we do here a lot. Over. Belgian, unfortunately we cannot hear you anymore. Just in case you hear me still, thank you everybody for the great questions. I wish you all the best, and goodbye from the International Space Station. Out.
Radio station ON4NOK in Turnhout, Belgium, operated by Kim ON4BCV and Eve ON6KX, contacted Alexander Gerst, KF5ONO, about the International Space Station. talking with students of the Sint Jozefcollege Turnhout, Belgium. For the international volunteer team of ARIS, including the radio amateur satellite corporations all around the world, the Amateur Radio Relay League, the UBA, CSA, ESA,